So what is TorchVision utility functions for visualization? So why visualization is important? The very first key idea here is deep learning models, especially in computer vision, produce outputs that are hard to understand numerically. So examples of in object detection, we coordinates and numbers, segmentations, tensors is pixel scores. Without visualization, you don't know if the model is correct. You can debug problems. So the key insights here is visualization is our eyes into the model. From the text, it helps detect wrong image loading, helps detect bad augmentations, it helps understands where the model is confident, it helps build trust. We could think of like training a model without visualization is like a flying blind. So, what is TorchVision visualization tools? TorchVision gives utilities to draw predictions directly on images. The two main ones is draw bounding boxes. It's used for object detection, and draw segmentation masks used for segmentation. Detection and bounding boxes. What is object detection? It answers what objects, where is it, so the output is bounding box, like according to x sub 1, y sub 1, x sub 2, y sub 2, like um, the minimum x value, the minimum y value, and the maximum x and y values. So, and it has a label, like for example, car or dog, and it says confidence scores. Example, manual boxes, we define the boxes like x sub 1, y sub 1, x sub 2, y sub 2, and it has the labels. So some of its output is it has an image with rectangles plus labels. So real model is a faster RCNN. They use in faster RCNN plus ResNet 50 plus FPN. What each part does, um, component, um, the component of this is faster RCNN, and the role is to find objects. ResNet 50, its role is extract features. Component FPN, it detects objects at different sizes. What is COCO dataset? Model is trained on 90 objects classes plus background, some labeled as NA or not applicable. Examples, car, traffic light, person. Important step is to get class names. They use a helper functions to read, like weights that beta. Why? Because model outputs numbers like class indices. We need names like car or dog. Detection pipeline. This is very important. Here, the full logic is step 1 is convert image to tensor. Step 2, run the model. And the output contains or predicts box labels and scores. Step 3 is filter predictions. The score should be greater than the threshold. Like our sample, the threshold is 0.7, or the minimum value that saying that this one be confident in the enough if the score is zero point 0.7 or greater than 0.7, this one um, is the right prediction. Next is select target classes, example car, traffic light. Next is step 5, to draw boxes, like draw bounding boxes. For example, we set the red for the cars, we set the blue for the traffic lights. Next is return annotated image. So the key insight here is detection is filter plus visualize. Next is segmentation, pixel level understanding here. So what is segmentation? Instead of boxes, it classifies every pixels. Example, this pixel is dog, this pixel is background. The model uses DeepLab v3 plus ResNet 50. So the output of segmentation model is output of shape is equivalent to um, in the index we have the number of classes, height and width. So each channel has a class score map. So important step here is argmax. So like example, outputted argmask dim 0. This picks the best class per pixel. So next is height and width. Each pixel now has a class index. Next is create a boolean mask. Um, like if it's true, it's a dog. It is false, not a dog. Next is prepare image for drawing. Image multiplied by 200 divided by y, because drawing function expects I uint 8 or unsigned int from 0 to 255. Next is draw segmentation mask. Draw segmentation mask with the image mask and having an output 0.05 and the 0.5, which means how transparency it is. And the final result is dog highlighted with semi-transparent overlay. Next is full pipeline summary. So this module that we have is it teaches what is the TorchVision ecosystem from the datasets, models, transforms, visualization. Next is pre-processing, verbalize images, convert to tensor, add batch dimension. Next is data handling, custom datasets and data loader. Next is pre-trained models, load weights, perform inference, use transfer learning. Next is visualization. We draw bounding boxes, draw segmentation masks. So this is a deep understanding. So detection versus segmentation. The feature is output. So detection is boxes. Segmentation is pixel mask. And when it comes to precision, detection is low. The segmentation is high. And like for example, in the detection, car location, and segmentation, exact car shape. So confidence threshold here is if score is greater than thresholds. So the controls is precision versus recall. Higher threshold, fewer predictions, more accurate. Lower thresholds, more predictions, more noise. Why visualization matters? So you cannot determine if your model performing correctly without visualization. Next is real-world applications from object detections of driving cars, security cameras. Segmentation is for medical imaging, background removal, photo editing apps. So the final model here is think of like detection. There is a dog here, but the segmentation, this is exact pixels are the dog.